Welcome back guys sa aking channel at dito nga ay didiscuss ko ang solving quadratic equations by extracting square roots. Solving quadratic equations by factoring. Solving quadratic equations by completing the square. Solving quadratic equations by using the quadratic formula. Bago po tayo magpatuloy, pwede po bang isubscribe nyo na ang aking channel at i-hit na rin po ang notification bell para updated po kayo sa mga sunod-sunod na videos na i-upload ko dito. As I said before, on this video, I will discuss solving quadratic equation and this is extracting square roots. Pakita ko muna sa inyo ang tabulations ng squared number and square roots. Ipinapakita diyan na ang lahat ng squared numbers ay meron siyang perfect square root. Halimbawa, yung 6 squared equals 36. Ibig sabihin, ang square root ng 36 is positive and negative 6. Halimbawa, si 11 squared equals 121. Square root of 121 is positive and negative 11. Note, bawat square root ay may dalawang value, the positive and negative. Yung positive, ang tawag doon ay principal root. Examples of quadratic equations that can be solved by extracting square root. Number 1, x squared equals 36. To solve, get or extract the square root both sides. Square root of x squared is x. Square root of 36 is positive and negative 6. Therefore, the value of x equals positive and negative 6. Number 2 example. X squared minus 81 equals 0. First thing to do is transpose negative 81 from left to positive 81 to the right. Next, extract square root both sides. Square root of x squared is x. Square root of 81 is positive and negative 9. Therefore, x equals positive and negative 9. Problem number 3. 9x squared minus 4 equals 0. Again, transpose negative 4 from left to positive 4 to the right. Extract square root both sides. Square root of 9x squared is 3x. Square root of 4 is plus and minus 2. Divide 3 both sides. Cancel 3 from x. Therefore, the value of x are positive and negative 2/3. Example number 4. 5x squared minus 45 equals 0. Again, transpose negative 45 from left to positive 45 to the right. Since 5 is not a squared number, we cannot get or extract square root. What shall we do first is divide 5 both sides. So cancel ang 5 from x squared. 45 divided by 5 is 9. Extract square root both sides. Therefore, the value of x equals positive and negative 3. Problem number 5. Quantity x minus 80 squared minus 144 equals 0. Transpose 144 to the right, it will become positive. So we have quantity x minus 8 squared equals 144. To remove squared, extract square root both sides. Square root of quantity x minus 8 squared is x minus 8. Square root of 144 equals positive and negative 12. Then, transpose negative 8 to positive 8 to the right. So we have 8 plus and minus 12. To solve them separately, our x sub 1 or the first value of x is 8 plus 12. X sub 2 or the second value is 8 minus 12. Solve individually. 8 plus 12 equals 20. 8 minus 12 equals negative 4. Therefore, the values of x are 20 and negative 4. Number 6. Quantity 2x plus 3 squared equals 225. Extract square root both sides. Square root of quantity 2x plus 3 squared equals 2x plus 3. Square root of 225 is plus and minus 15. Transpose positive 3 from left to negative 3 to the right. So we have 2x equals positive and negative 15 minus 3. Divide 2 both sides, cancel 2 from x. Our temporary values of x is plus and minus 15 minus 3 all over 2. So our x sub 1 or the first value is 15 minus 3 over 2. 15 minus 3 is 12 divided by 2 equals 6. For the second value, negative 15 minus 3 equals negative 18 divided by 2 equals negative 9. Therefore, the values of x are 6 and negative 9. Seventh and last problem for this video. 4x squared plus 100 equals 0. Transpose 100 to negative 100 to the right. So we have 4x squared equals negative 100. Divide 4 both sides. So cancel ang 4 from x squared. Negative 100 divided by 4. So we have x squared equals negative 25. This problem is different from above because the value of k is negative. Since k is less than 0, property number 3 states that if k is less than 0, then x squared equals k has no real solutions or roots. Therefore, that particular problem has no real solutions or roots. Solving quadratic equations by factoring. Steps in solving quadratic equations by factoring. Step 1. Transform the equation into standard form if necessary, or in the form of ax squared plus bx plus c equals 0. Step 2. Factor the quadratic equation. Step 3. Apply the zero product property by equating the factors to 0. Step 4. Solve the resulting linear equation. Step 5. Check the values by substituting to the original equation. And Step 6. State the final answer. For this time, we will solve some quadratic equations by factoring. Number 1, x squared plus 6x equals negative 8. First to do is to transform the equation into its standard form by transposing negative 8 from right to positive 8 to the left. Since the quadratic equation is already on its standard form, factor the equation by trial and error or the so-called TAE method. The factor of x squared equals x times x. And to determine the operations of the factors, please be reminded of this 3 columns table. In the first column, we have sign of the last term. In the second column, signs of the middle term. And for the third column, operations of the factors. Since the last term is positive and the middle term is positive, the operations of the factors are both positive. Since the last term is positive and the sign of the middle term is negative, the operation of the factors are both negative. And if the sign of the last term or third term is negative, no need to consider the sign of the middle term. The signs or the operations of the two factors, one plus and the other is minus. In our problem, we are on the first case where the sign of the last term and the middle term are both positive. Therefore, the operations of the factors are both plus or addition. Then, match the factors of the first term by the possible factors of 8, which are 2 times 4 and 1 times 8. Let's try first the factors 2 and 4. To check if the factor combinations are correct, let us add the product of the inner terms, which is 2 times x is 2x, and the product of the outer terms, which are x times 4 equals 4x. Let us now add 2x plus 4x equals 6x and match it to the middle term of the quadratic equations. Since they are both 6x, the expressions quantity x plus 2 and quantity x plus 4 are the factors of the quadratic equation x squared plus 6x equals negative 8. Next is apply the zero product property by equating x plus 2 equals 0 and x plus 4 equals 0. Solve the linear equations separately. X equals negative 2 and x equals negative 4. Substitute the values to the original equation to check which of negative 2 and negative 4 or both of them are the solution. Substituting negative 2 to the original equation, we have negative 2 squared equals positive 4. 6 times negative 2 equals negative 12. 4 minus 12 equals negative 8. Since they are equal, negative 2 is a solution. Doing the same to negative 4, and since they are also equal, negative 4 is also a solution. This part of checking is optional, particularly if you are confident with the solutions above. In this problem, the value of x equals negative 2 and negative 4. Problem number 2, solve by factoring x squared minus 7x minus 30 equals 0. The factors of the first term x squared are x and x. And since the third term is negative, no need to consider the sign of the middle term. The sign of the factors are plus and minus. The factors of 30 that can be used for the trial and error method are 5 times 6, 3 times 10, 2 times 15, and 1 times 30. First to use factors of 30 are 5 and 6. Negative 5 times x equals negative 5x. X times 6 equals positive 6x. Adding them, negative 5x plus 6x equals positive x. Since positive x did not match to the middle term which is negative 7x, the factors x minus 5 and x plus 6 are not correct. Next, let us try 3 and 10. Negative 3 times x is negative 3x. X times 10 is positive 10x. Negative 3x plus 10x equals 7x. In this case, 7x also is the middle term but opposite in sign. Therefore, what shall we do is we will reverse the sign. Minus will become plus and plus will become minus, so that the factor combinations will become correct. Applying the zero product property, we have x plus 3 equals 0 and x minus 10 equals 0. Solving them separately, positive 3 transposed to the right will become negative 3, and negative 10 transposed to the right will become positive 10. Again, checking the values to the original equation is optional, particular if you are confident with your above steps. Therefore, the solutions for the quadratic equations are x equals negative 3 and positive 10. Number 3 problem, solve 2x squared plus 13x equals 15. Once again, change the quadratic equation into its standard form by transposing positive 15 from right to negative 15 to the left. The factors of the first term 2x squared are 2x times x, and since the last term is negative, the operations of the factors are plus and minus. To check if the factors are correct, 3 times x equals 3x, 2x times negative 5 is negative 10x, 3x minus 10x is negative 7x. Since negative 7x did not match to the middle term which is positive 13x, the factor combinations are not yet correct. Since the factors of the first term are not equal, unlike the other past two examples, we can interchange the factors of the third term. 3 will become 5 and 5 will become 3. 5 times x is 5x, 2x times negative 3 is negative 6x, 5x minus 6x is negative x. Again, negative x did not match to 13x, therefore the factor combinations are still not correct. Let us try also the other factors of 15, which are 15 times 1. 15 times x equals 15x, 2x times negative 1 is negative 2x, 15x minus 2x equals 13x. Since 13x matched the middle term, therefore the factor combinations quantity 2x plus 15 and quantity x minus 1 are now correct. Applying zero product property, we have 2x plus 15 equals 0 and x minus 1 equals 0. Transpose positive 15 from left to negative 15 to the right. Divide both sides by 2, x equals negative 15 over 2. Transpose negative 1 to positive 1 to the right. So x equals 1. Therefore, the roots of the quadratic equation are x equals negative 15 over 2 and 1. Fourth and last problem for this video, solve by factoring 2 quantity 3x squared minus 1 equals 11x. To change to its standard form, first remove the parentheses by distributive property. 2 times 3x squared equals 6x squared. 2 times negative 1 is negative 2. Then, transpose positive 11x to negative 11x to the left. The factors of the first term 6x squared equals 2x times 3x. The factors of the third term 2 is 2 times 1. Since the third term is negative, the operations are plus and minus. 2 times 3x equals 6x. 2 times negative 1 is negative 2x. 6x minus 2x equals 4x. 4x did not match to negative 11x of the middle term. Therefore, the factors 2x plus 2 quantity 3x minus 1 are not yet correct. Next is to interchange the factors of the third term. 2 will become 1 and 1 will become 2. 1 times 3x is 3x. 2x times negative 2 is negative 4x. 3x minus 4x equals negative x. Again, negative x did not match to negative 11x. Therefore, the factors combination are still not correct. This time, we will try the other factors of 6x squared, which are x times 6x. Using the same factors of 2, which are 2 times 1. 2 times 6x is 12x. X times negative 1 is negative x. 12x minus x is 11x. Since 11x is the opposite of the middle term negative 11x, what we will do to the operations will be reversed. Plus will become minus and minus will become plus. For this time, the factor combinations x quantity x minus 2 and quantity 6x plus 1 are now the correct factors of the quadratic equation. Applying zero product property, x minus 2 equals 0, 6x plus 1 equals 0. Solving them separately, transpose negative 2 will become positive 2. Transpose positive 1 will become negative 1. Divide both sides by 6. X equals negative 1/6. Once again, checking the values to the original equation is optional. Therefore, the roots of the quadratic equation using factoring are x equals 2 and negative 1/6. Solving quadratic equations by completing the square. The following are the steps in solving quadratic equations by completing the square. Step 1. Divide both sides of the equation by a, then simplify. Step 2. Transpose the constant to the right. Step 3. Add the square of the half of b or quantity b over 2 squared on both sides. The left side of the equation will become perfect square trinomial. Step 4. Express the left side as a square of binomial. Step 5. Solve by extracting square root. Step 6. Check the solutions to original equation. And Step 7. State your final answer. Problem number 1. Solve by completing the square. 2x squared plus 8x minus 10 equals 0. First to do is to remove the coefficient 2 on the first term. So we will divide both sides by 2. 2x squared divided by 2 is x squared, 8x divided by 2 is plus 4x, negative 10 divided by 2 is negative 5, 0 over 2 equals 0. Next, we will transpose the constant negative 5 to the right. From negative, it will become positive. Then, we will do the completing the square on the left side by looking or solving its constant. To find the constant or c, it is quantity b over 2 squared. B is the coefficient of the second term, which is 4. So, 4 over 2 is 2. 2 squared is equal to 4. 4 will be added to the left and also will be added to the right. Simplify the right side. 5 plus 4 equals 9. The left side expression x squared plus 4x plus 4 is now a perfect square trinomial whose factor is quantity x plus 2 squared. To remove squared, extract square root both sides. Square root of quantity x plus 2 squared equals x plus 2. Square root of 9 is plus and minus 3. Then, transpose positive 2 to negative 2 to the right. To determine the two values of x sub 1 equals 3 minus 2 and x sub 2 is negative 3 minus 2. Individually solve the equations. 3 minus 2 equals 1, negative 3 minus 2 is negative 5. To determine if 1 or negative 5 or both are solutions, solve the values to the original equation. By substituting 1, we have 1 squared equals 1, 4 times 1 equals 4, plus 4 equals 9. 1 plus 4 plus 4 equals 9. Since they are equal, 1 is a solution. Do the same to negative 5, substitute to the original equation, and as you see on the solution at the right side of the screen, 9 also is equal to 9. It means that negative 5 is also a solution. Therefore, the solution for the equation by completing the square is 1 and negative 5. Problem number 2, x squared plus 8x equals negative 15, solved by completing the square. Since the constant negative 15 is already on the right side, we will now do the completing the square on the left side. The value of b is 8, divided by 2 is 4, 4 squared equals 16. 16 will be added to both sides of the equation. Simplify the right side, negative 15 plus 16 equals positive 1. The left side expression x squared minus 8x plus 16 is already a perfect square trinomial whose factor is quantity x minus 4 squared. Again, to remove the squared on the left side, extract the square root both sides. Square root of quantity x minus 4 squared equals x minus 4. Square root of 1 equals positive and negative 1. Transpose negative 4 to positive 4 to the right. X equals positive and negative 1 plus 4. To get the two values of x sub 1 equals 1 plus 4, x sub 2 equals negative 1 plus 4. 1 plus 4 equals 5, negative 1 plus 4 equals 3. To determine if 5 and 3 are solutions or not, solve them to the original equation. And as you see the solutions on the screen, both of them hold true on the original equation. Therefore, we can now say that the solutions for the quadratic equation by completing the square is 5 and 3. Problem number 3, solve by completing the square. 4x squared minus 21x plus 5 equals 0. Again, first to do is remove the coefficient 4 on the first term by dividing both sides by 4. And it is equal to x squared minus 21 over 4x plus 5 fourths equals 0. Then transpose the constant 5 fourths to negative 5 fourths to the right. Next, do the completing the square on the left side by solving its constant. Again, the formula to solve for the constant is half of b squared. The value of b is 21 over 4 divided by 2. To divide fractions, copy the numerator which is 21 over 4. From division, proceed to multiplication. Get the reciprocal of 2 which is 1/2. To multiply fractions, multiply numerator to numerator and denominator to denominator. 21 times 1 is 21. 4 times 2 is 8. Then, square the result. 21 squared is 441. 8 squared is 64. To continue, add 441 over 64 to both sides of the equation. Since the right side are two different fractions, we will solve this using 64 as LCD. 64 divided by 4 is 16 times negative 5 equals negative 80. 64 divided by 64 equals 1 times 441 equals 441. Simplify the numerator. Negative 80 plus 441 equals 361 over 4. The left side expression x squared minus 21 over 4x plus 441 over 64 is a perfect square trinomial whose factor is x minus 21 over 8 squared. To solve for x, extract its square root, both sides. Square root of quantity x minus 21 over 8 squared is x minus 21 over 8. Square root of 361 over 64 equals plus and minus 19 over 8. Transpose negative 21 over 8 to the right, we have 21 over 8 plus and minus 19 over 8. To determine the two values of x, x sub 1 equals 21 over 8 plus 19 over 8. 21 plus 19 equals 40 over 8. 40 divided by 8 equals 5. Its second value, or x sub 2, equals 21 over 8 minus 19 over 8. 21 minus 19 equals 2 over 8. Simplest form equals 1/4. Therefore, the solutions for the equation by completing the square is 5 and 1/4. Solving quadratic equations by using the quadratic formula. All quadratic equations on its standard form, ax squared plus bx plus c equals 0, can be solved using the quadratic formula. X equals negative b plus and minus square root of b squared minus 4ac all over 2a. The following are the steps in solving quadratic equations using the quadratic formula. Step 1, write the equation in standard form. Step 2, determine the values of a, b, and c respectively. Step 3, substitute the values of a, b, and c to the quadratic formula. Step 4, solve the equation and simplify. Step 5, check the values against the original equation. And step 6, state the final answer. Problem number 1, solve using the quadratic formula the equation x squared plus 2x equals 35. Transpose positive 35 to negative 35 to the left to transform the quadratic equation into its standard form. Then identify the values. A equals 1, b equals 2, and c equals negative 35. Substituting the values on the formula, we have negative 2 plus and minus square root of 2 squared minus 4 times 1 times negative 35 all over 2 times 1. Continue, 2 squared equals 4. Negative 4 times 1 times negative 35 equals 140. 2 times 1 equals 2. 4 plus 140 equals 144. Square root of 144 equals 12. So the temporary values of x equals negative 2 plus and minus 12 all over 2. The first value of x is negative 2 plus 12 all over 2. Negative 2 plus 12 equals 10. 10 divided by 2 equals 5. The second value of x equals negative 2 minus 12 all over 2. Negative 2 minus 12 equals negative 14. Negative 14 divided by 2 equals negative 7. Therefore, the solutions for the quadratic equations are 5 and negative 7. Problem number 2, solve using the quadratic formula the equation 3x squared minus 13x plus 14 equals 0. Since the equation is already on its standard form, we can now determine the values needed. A equals 3, B equals negative 13, and C equals 14. Substituting the values on the formula, we have negative of negative 13 plus and minus square root of 13 squared minus 4 times 3 times 14 all over 2 times 3. Continue to simplify. Negative times negative 13 is positive 13. 13 squared equals 169. Negative 4 times 3 times 14 equals negative 168. 2 times 3 equals 6. Simplify next. Square root of 169 minus 168 equals square root of 1. Square root of 1 equals 1. Once again, the temporary values of x equals 13 plus and minus 1 all over 6. The first value of x equals 13 plus 1 all over 6. 13 plus 1 equals 14 over 6. 14 over 6 simply as form equals 7 over 3. The second value of x equals 13 minus 1 all over 6. 13 minus 1 is 12. 12 divided by 6 equals 2. Therefore, the solutions for the quadratic equation is 2 and 7/3. Problem number 3, 2x squared plus 3x plus 15 equals 0. Since it is on its standard form, we can now get the values of a, which is equal to 2, b equals 3, and c equals 15. Next, substitute these values on the formula. 2 for a, 3 for b, and 15 for c. Then simplify the exponent first. 3 squared equals 9. Then multiply negative 4 times 2 and 15 equals negative 120. 2 times 2 equals 4. Next, simplify or subtract 9 minus 120 equals negative 111. Since the square root of negative 111 has no real value, you can now stop your solution and you can now have your conclusion that the quadratic equation has no real roots or solution. Kung nakatulong po at nagustuhan ninyo ang video, please like. At paki-share na rin po para tuloy-tuloy ang pagtulong natin sa iba.